What if you don't know the exact formula of a physical quantity, but you know it depends on a few others, like mass, length, or time? Using dimensional analysis, you can derive a relationship between them. Let's learn how to deduce formulas using only dimensional reasoning. Suppose a quantity Q depends on three other quantities, A, B, and C. We assume Q equals K multiplied by A to the power A, B to the power B, and C to the power C. Here, K is a dimensionless constant. A, B, and C are the powers to be determined. We then write the dimensions of both sides and compare powers of M, L, and T. Let's derive the time period T of a simple pendulum. We assume it depends on length L, dimension L, mass M, dimension M, acceleration due to gravity G, L times T to the power minus 2. So we write T is equal to K times L to the power A times M to the power B times G to the power C. Now write dimensions. LHS, T, time, dimension T. Write SL to the power A equals L to the power A, M to the power B equals M to the power B, G to the power C equals L to the power C times T to the power minus 2C. From the dimensional equation, T equals L to the power A plus C times M to the power B times T to the power minus 2C. Now compare exponents. For M, power on LHS is 0, so B equals 0. For L, power on LHS is 0, A plus C equals 0. For T, power on LHS is 1, minus 2C equals 1, so C equals minus 1/2, A equals 1/2, B equals 0. Final relation, T equals K times L to the power 1/2 times G to the power minus 1/2, which is T equals K times the square root of L divided by G. We now know the form of the formula without any experiment. Dimensional deduction is useful to predict the form of equations, identify dependencies between quantities, save time when experimental data isn't available. But remember, it can't give numerical constants like 2 pi. It only works when all variables involved are known. It doesn't work if quantities have identical dimensions. Still, it's an excellent estimation tool. Dimensional analysis lets you build the skeleton of an equation using logic and known quantities, a powerful way to predict, test, or verify relationships in physics. With this, we conclude Chapter 1, Units and Measurement. Great job completing your first physics concept.